put this in presentation mode. Can you guys see okay?
This works. So Danny Tam, for anyone who does not know, is one of the lead mechanical engineers at the Energy Commission. He came on, I think, maybe 6 years ago? So 8 years ago? How long ago did you join the Energy Commission?
I've been here 10 years, actually.
10 years. I apologize. I didn't meet you right away.
No problem.
But the entire time I've known you, you've been the technical lead on how to address central hydronic systems for heat pump hydronics and also heat pump domestic hot water, and particularly the central systems, which are so complicated because of the issues of return temperatures and such. So I don't want to make your presentation for you. I just want everyone else to know that what Danny is doing effectively is building into California software, which is arguably the most advanced software, particularly around heat pump water heating. I think it's inarguably the most advanced software that we have in our country for that, heat pump water heating. So, and Danny is improving it. He's making it accurate to research that we have out there, and he's building it into the software. And I am so excited because so many other people are so excited, you know, with 25 cities having adopted REACH codes or gas bans that essentially promote central heat pump water heating where appropriate. I'm so excited that you are rolling out the next version of the software and the standards. So with that, I will mute myself and thank you so much, Danny, for your time here.
Oh, thank you for the introduction. Hi, everybody. I'm Danny Tam from the California Energy Commission. I'm in the Title 24 office, and I'm going to be giving a quick overview of central heat pump water and the current status in Title 24, and just a little preview on the software. So just so everyone's on the same page, there's two different kinds of water heating system in Title 24. The single dwelling system is typically what you see in, single family home. You have, a water heater that serves a single dwelling, or it could be in a multifamily building that each unit has its own water heater. We consider those single dwelling systems. And then for central systems, are systems that one or more systems serves multiple dwelling units in the multifamily setting. So up till recently, most central systems in California uses natural gas. As the state transitioned from a ZNE goal to a zero carbon decarbonization goal, it's very important that we flip this around. So some of the challenges for central heat pump water heater, fundamentally they're different than gas boiler systems. You cannot design a gas boiler and just swap in a heat pump and just expect everything to work. Heat pump, moves heat, so it recover heats much more slowly. So typically it needs more storage volume than a gas system. And it's important to separate the primary heating load from the temperature maintenance mode because, heat pump does not like, warm inlet water. The primary heating load is, load from taking a shower or cooking, and the temperature maintenance is just keeping the loop warm. So when someone take a shower at 1 in the morning, it doesn't take 15 minutes for the hot water to get to the user. Also, different central heat pump water heater has different refrigerant, and they perform slightly differently. They could be single pass and multi pass. For instance, you don't want to use a single pass heat pump to do temperature maintenance. It's probably not going to perform very well. Another issue is a lot of these equipment are not federally regulated. The smaller heat pump, they're rated by DOE. They have a UEF rating, but these bigger systems, there's no standardized testing procedure. They're not regulated. So there's a lot of uncertainties of how these systems perform in the real world. And finally, the one that most people care about is lack of modeling capability. Up till now, we don't have the capability to model these complicated heat pump system. Unlike single family, you just put in the water heater, you connect the water connection and the electrical, and you're done. These are built-up systems. So actually, we've been working on this for quite a few years. Until recently, about 6 months ago, it became a critical task for us when a number of local jurisdictions adopted all-electric codes. So in the past couple of months, we've been working, full blast to come up with some sort of solution. So the Commission has came up with a 3-phase plan, and this is just to wake everyone up. If you don't know what underpants norms are, you can Google it, you get a good chuckle. But I assure you our 3-phase plan is a little more, much higher chance of success. So we have a 3-phase plan for implementation of central heat and water heater. Phase 1, part of this is already has been in place. So first part of phase 1 is we have a executive director approved prescriptive option for central heat and water heaters. This is a very limited in scope, and I'll go over that in the next slide. And as part of that, we have developed a physics-based model, again, limited in scope to gang split system heat and water heater, i.e. a Zanden-based system. So that should be, we've been testing the physics-based model for the last few months, so it should be on the street very soon. Phase 2 is our plan to tackle the issue of these larger systems that's not regulated. So we're proposing to have a process for a manufacturer to report some performance data to us so we can build a performance map for these systems. And so we're going to have a self-reported declaration and data sheet, and manufacturer will submit that information to us, and we'll try to work that into software. And then phase 3 is the PG&E lab testing. They has actually already started testing these large central systems. So the goal is for the PG&E lab test to true up what's in the physics-based model, and the manufacturer submit the data.
Danny, underpants norms is outrageous. That is.
Yeah.
That's, thank you.
It's too perfect, right? It's 3-phase. It's like, man, Google if you don't know what it is. So anyway, so this is another graphic. So the first 4 is basically phase 1. We have the executive director approval already in place. We have exceptional design. That's actually always an option. If you have a design that doesn't fit into, we're not able to model, we can always approve exceptional designs. And then CBEC 1.2 should be released very soon. That has the Zanden capability. And in the back end, we've been working on the forms. And then we should be releasing the manufacturer self-certified declaration very soon. And then we'll start incorporating those into CBEC. And then in the background is the PG&E testing. Some overview for the prescriptive options. Like I said, it's very limited in scope to the split system heat pump. We got required you to separate the primary heating load from the temperature maintenance load, which means we'll require primary storage tank and a loop tank, and which means we also require a separate loop heater for the temperature maintenance. Currently, we assume that's an electric resistance water heater. In the future, we should be able to allow other systems. There's also some sizing equipment based on number of bedroom and dwelling units. You need to have a minimum number of compressors, minimum primary tank volume, and a loop tank volume. And also for the first time, just a brief background, for all central systems, there's a prescriptive requirement for solar thermal. It's 20% from climate zone 1 to 9 and 35% for chromosome 10 to 16. And part of this central heat pump water heater prescriptive alternative is that we're going to allow some PV trade-off in place of that solar thermal requirement. So this is what this system would look like. You have these compressors on the left that feeds into a primary storage tank. It could be one or a number in series, and that feeds into the loop tank. And the loop tank is where it connects to the recirc loop. So the recirc temperature maintenance load is separated from the primary load. And I'm just going to glance. We're going to do an actual demonstration. So you can see, you can model a central system with a stand-in. Currently, it's only limited to stand-in, but as we got more data from the PG&E testing and manufacturer submitted data. More manufacturers should be open. So you input the loop tank volume. You can auto-size number of compressor, or you can put in the actual number, the primary tank volume. And we also did some work on the solar thermal calculation piece. Currently, it's a separate calculator, which is quite out of date. So we're going to incorporate that calculation into CBAC itself. So it's going to be much more accurate.
One second, I just applaud you, like, woo! Thank you. It's been like the most garbage part of that software where numbers made no sense past like 20% offset. Anything that you tried to put in over that was just a crapshoot. Whatever answer you got was whatever answer you got, but it made no sense. Okay.
It's outdated. We just didn't have the resources to fix it, but now, it's.
Oh, I know. That's why you get applause. Like, yay!
Oh, thank you. Thank you. So this is an example of what we're asking the manufacturer for to build our performance curve. So we were asking for, the operating temperature maximum, ambient air temperature, and different input power and output capacity. So this should help us, develop a performance curve similar to what we did with the near heat pump water heaters. PG&E lab test has been commissioned. They already start testing the small systems. So that's a quick overview on the current status. I'm going to switch over to.
Can I ask a question real quick?
Yeah.
Could you go to slide 8?
Which one is 8? Okay.
There we go. So you have here 2 single pass heat pumps. Is that the correct understanding for how this prescriptive layout is? Is it, how many go into a storage tank?
It depends on the number of dwelling and number of bedrooms. It's just an example. It could be 1, it could be 20. It depends on what building it goes into.
Ah, okay.
So I would read our prescriptive requirement. That was docketed last month. If you don't have it, I can send it to you.
I definitely appreciate you bringing it back to my attention. Sorry I missed it.
Yeah, it's just an example. In this example, there's 2 compressor. Obviously, a bigger building will need more capacity.
I just want you to be aware that in our EPIC research, we found that the 4-to-1 ratio, 4 compressors to 1 storage tank, and it wasn't 80 gallons, it's like 300 or something, but that 4-to-1 ratio, all 4 compressors seemed to work and be controlled correctly. And then when we got to more than 4, we started having some not come on, or the COP dropped. For whatever combination of reasons, our COP was much lower overall with systems that had more than 4 compressors. That's it, without trying to even get too much into all the possible reasons or what we think are the reasons, etc. That's what we found.
So right now the primary storage tank is sized as 1 compressor to 80 gallon, I believe, if I remember correctly. So it's not just, 4 compressor to 1 storage tank. It's based on volume.
Right. And I think what happened was controls based. And because Sandon doesn't have their own controls, they're at best using the Colmax control system. But that was part of what we did in the research, was to implement that Colmax control. But so I think that's the issue, is we found that the Colmax control could handle 4 well.
So hang on. So this is the more technical drawing. So you can have, I think these compressors in parallel, and it feeds to these storage tank in series. So I think we call for having the sensor at the middle of the series. So I don't know if that would fix some of the issues that you're seeing.
Good question. That was an experiment, and the research money was spent on improving the system iteratively until we felt like we got it working right. But this hopefully is the distillation of that wisdom, and others, obviously.
Yeah, so I mean, this is very specific to the Sandon. Colmax can be, different.
Right. It was Sandon systems with Colmax controls to coordinate.
With Colmax control. Okay, interesting. Okay. Yeah, we can talk offline.
Yeah, continue. But thank you for clarifying and just digging into it.
Okay. No problem. Can you see the CBEC screen?
I can.
Okay. So this is a sneak peek. This is a 1.2 RC. So let's see. So this is 8-unit prototype, 6960. In this example, I have essential heat pump water heater selected. You can see it's a Sandon. Currently, it's only limited to Sandon. 80 gallon loop tank volume, 2 compressor, 160 primary tank. Let's see. And it's Climazone 3. I'm just going to run it, and you can see the results. Hopefully it won't take too long.
Well, the question that's been on everyone's mind is, when does this get released to the public?
So 1.2, as I understand, it's very soon. Maybe in the next couple of weeks.
Ooh, that's really soon. I was expecting March or something. That's terrific news. Well, there's not.
Yeah, they've been testing it for a while. Central heat pump water is just one thing, one of the primary items they're trying to add. But yeah, it is almost ready.
Excellent.
Uh-oh.
Oh, there are questions in the chat box, apparently. Emily asked, is the Sandon model that is going to be released based on PG&E data? The Sandon model.
That one is the physics-based model that Bruce Wilcox and his team helped us develop. So PG&E is testing the Sandon system. I think within the next couple of months. So as soon as we have those testing data, we'll true up what we have, and we might make some adjustments.
Will CBEC-COM also have the central heat pump water heater functionality?
Yes. So CBEC-COM uses the CBEC-RES module for domestic hot water, so it should match. So Climazone 3. So the standard design is still based on a gas boiler. So you can see when I use the Sandon. So I want to say without a solar thermal system, it actually beat the standard design budget.
And the standard design is like an 81 or 2% efficient boiler or something?
Right, it's an 82 boiler plus a
20%
solar thermal system. So the Climazone 3 is 20. So when I go to 12, I'm going to run this. It's going to be slightly behind because the solar thermal requirement switches. is slightly higher for the standard design. But I want to show you maybe some additional credit you can try.
That's really cool, though, that the heat pump sometimes beats gas plus solar thermal, and sometimes it's just a little bit behind without solar thermal. All right.
It is pretty slow sometimes. Sorry, guys.
It's okay. We all know. So a third question here, Jim Lutz was asking, what modeling tools and algorithms did you use to cost energy justify this prescriptive option? Is that publicly available yet?
It's a prescriptive alternative, so we don't need to do cost effectiveness analysis for compliance options.
Oh, good.
It is different than if we actually put this in the standard, then yeah, we have to cost justify it. But since it's a compliance option, any compliance option actually, we don't have to do cost effectiveness.
Right. Okay, terrific. Thank you.
So Climstone 12, you can see is a little bit worse than the standard design. Sean, I think I mentioned to you before, under the recirc loop, there's a number of things you can do. I'm going to increase the loop insulation thickness from 1.5 to 2 and see what happens.
Oh, cool. Can you increase it to like 4 inches?
You can try it. You can model it if you want. Might not be physically possible to do 4 inches, but you're free to try.
In parking garages, I mean, various distribution places where there's actually 12 inches of space there. That's where that might be appropriate, especially exposed to outside air, like in a parking garage. Whereas exterior walls, you can probably do more than 2 inches on both sides of a pipe.
Okay, well, yeah, it's in the software. You're free to try.
Cool.
Come on. So by upping the insulation by half inch, it's almost there. It was like 28, right? So a couple of other things I want to show you guys. We did some work on solar too. We added this. One of the asks is, how do you model shading? So we added this annual solar access percentage. So a lot of software, like Aurora or Suneye Report, they give you an annual solar access percentage. So you can actually input that if there's a little bit of shading. So you can put a 90, and that will it will still allow you to input the system, but you probably need to add some more PV to make up the difference. Also you can add microinverters or DC power optimizer that will make your system perform a little bit better. I guess the big thing is we added a CFI2.
What's that?
So currently, California Flexibility Installation CFI1 is limited to 150 to 270. So we added CFI2 based on some feedback from the builders. CFI2 is going to be from 105 to 300. So that should be a lot more flexible for builders, so they don't have to redo the performance runs.
And what do you mean flexibility? This is around the angles away from true.
Yeah, orientation.
Oh, thank you. Okay.
Yeah, so if you can pick NA, you can put in the actual orientation of the array, or like for production builders,
right. No, that's
they just want to do CFI, they do it once and, be done. So we add CFI2 with a bigger azimuth range, but when you pick that, does require upsizing factor of 10%. So that's the trade-off. But it will allow them to not redo any performance runs. We are also thinking about CFI 3 with a 90 to 310 estimate range with a 15% upsizing, but we're still working on that. Okay, what else? I'm gonna go to single family real quick. In case people are not aware, pre-2019, all the water heating budget is based on like gas instantaneous water heater for single dwelling. But starting in 2019, the budget's got to switch to electric when you choose a heat pump. So I'm going to do a quick run. So someone mentioned RUD. I guess I should say, in our modeling, you can input the specific UEF you want, if you want, but you can also pick the specific model if it's a NEA-rated heat pump water heater. So I'm pick the RUD 50. You can pick, where it's located. Could be the garage or in one of the condition zones or outside. So, so this is a standard design house that exactly matched the standard design budget. So the only thing I change is the heat pump water heater. And just by that, you should be able to see a slight credit. So you can see just, putting an off-the-shelf heat pump water heater, you got a slight credit in the water heating budget. And another thing, we made some changes to the compact distribution. One thing we've been trying to push is that when you switch to a heat pump water heater, it's actually quite easy to also get the compact distribution credit. So it's almost like a 2-for-1, we think. So let's try that. So let's try to make the system that meets the basic credit. You get a 30% reduction in the distribution loss when you qualify for the compact distribution credit. So let's run that.
And briefly, what is that standard for what qualifies to meet that standard?
It's a weighted average between the water heater to the master bedroom, the kitchen, and the furthest fixture. There's some formula in the back end. So as long as you meet that qualification, you meet that credit.
Is it simple to? I mean, it
should be. We think it's fairly simple to do.
Okay.
So you can see, so it's just swapping the water heater. If that water heater also qualifies for the compact distribution credit, you got a 3.7% compliance margin, and that was the only thing I changed. So, I think this will be a good incentive for builders to electrify at least the water heating piece. So that's all I wanted to show you guys. Is one, Sean, do you have any questions?
Well, first of all, woo! Yay, Danny! That was fantastic. It seems like you've been answering questions as we went along. I was just looking over on the side to see if any remained. I want to draw people's attention that we just posted John Gross's. Okay, Ben Thompson asks, what would be the path to get a COMAC-based system approved?
Yeah, we're working on that as we speak. I think Ben Larson, our consultant, he's been talking to COMAC and Nile and others, and I believe he already has some data from COMAC. So he's working to build that performance curve, and again, we need to test it and see if the installation criteria is going to be a little bit different than the Sandon. But once we're ready, we'll put that in the software.
Do you need anything more than what you already have resources allocated for to accomplish this? Are we like, is there something that's just not there yet?
I talked to Ben last week at SMUT. He literally just got the information from COMAC.
Okay.
So, yeah.
Okay, so Dan Johnson asks, why would a heat pump water heater qualify for compact while the default gas would not?
We think it's easier to qualify. If I can find my compact presentation, hang on a second.
And Pete Kennedy, earlier the question was asked, does this go into CBEC-COM? And yes, so it appears to apply to high-rise as well. Yes.
High-rise for us, yes. So.
And, yay, thanks. Aw.
No problem. So let's see if I remember how this goes. So typically, it's typical house, you have a water heater on the outside wall. So, I mean, all we're thinking about is how do we, make this more efficient without changing much of anything else. You can do that by simply moving the water heater to, closer to the middle of the house. I'm just gonna go to this very quickly. So here's an example of two-story house. You have a water heater on the outside wall, very typical. In this particular example, it doesn't meet the basic credit. So you can see it's a weighted distance between the water heater and the master bedroom. So by moving the water heater from here to here, this house qualifies for the basic credit. And because heat pump water heater, you don't have to deal with, venting, we think it's much more flexible where you locate it, and it should be easier to qualify for the compact credit.
That's a great answer. Okay. I'm just trying to say, are there any other questions while we still have Danny here? Because it is not easy to get such high quality presentations. It's 1:04, by the way, and we're going to take a break, I think, for 20 minutes or so when Danny's done. Till 2. Oh, lucky us. We get a real lunch break. Okay, so